ओके ये क्वेश्चन हम सॉल्व करते हैं. दैट इज अबाउट द मोमेंट लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम इन टू डायमेंशंस. ओके, in this particular situation, either before collision the particles are moving with an angle, or maybe possible after collision the particles will go with an angle. Right now, before impact particles are moving with an angle and they will impact at one location. Say if we consider this point, this one, all right, and after impact they all traveling with a straight line. So it means okay, in this particular situation we have to look for the vector momentum resolution according to the vector resolution. All right, because law of conservation of momentum is only valid for a straight line motion. The law, in fact, true name is law of conservation of linear momentum. Or right now in this situation particles are before impact not traveling in a linear direction, so we have to take them in a linear direction. How? Let's start the question. A ball X moves along a horizontal line, horizontal frictionless surface, and collides with another ball Y as illustrated. Now the details are given. Ball X has mass, right? Ball and the velocity Vx at an angle 60 degree. Vx is not known to us. Velocity for ball Y is given to us. So first of all, do one thing. Resolve the velocity for both the particles according to the direction. Okay, so I am making a triangle, right angle triangle for right now Vx. Now 60, you know, angle in front of angle theta ke samne we have always a sine, so I can say this is sine Vx. Okay, and this will be cos Vx, this side. Now if we look for the arrows, sin Vx pointing downward, cos Vx pointing towards right. ये फ़िलहाल मैंने ऊपर वाली Vx की वेलोसिटी को रिजॉल्व किया है. Vy को अगर मैं साइड में रिजॉल्व कर लूँ, फॉर इंस्टेंस विद अनदर कलर ताकि कन्फ्यूजन ना हो, मैं सिर्फ साइड में आपके रेफरेंस के लिए रिजॉल्व कर रहा हूँ. ये Vy यहाँ राइट इस डायरेक्शन में जा रहा है. ओके, so one component would be here and a one component is over here. Angle is given on this side. So अब arrow अगर यहाँ है तो one arrow will point in this direction and one arrow will point in this direction. So now 60 degree के respect से 6, the Vy is 6. All right, so this side is called sine 60 dot Vy cos 60 dot Vy. ये हमने दोनों की रेजोल्यूशन साइड में यहाँ रख ली है. नाउ लुक एट द क्वेश्चन. कैलकुलेट टू थ्री सिग्निफिकेंट फिगर्स the component of the initial momentum of ball Y that is perpendicular to line AB. Initial momentum of ball Y that is perpendicular to line AB. Now सिर्फ ball Y का initial momentum perpendicular to the line, this is perpendicular to the line, right? So it means he's talking about this particular, this side. It's talking about this side. Okay, so this is for ball Y, initial momentum before impact. Initial momentum obviously before impact hai, right? That is going to be mass of Y and velocity of Y, which is dot sine 60. Now mass of Y is 0.2 multiply by 6 into sine 60. इसको सॉल्व करते हैं, ठीक है. इट्स 0.2 इंटू 6 इंटू साइन 60. इट्स कमिंग 1.039 और वी कैन यूज़ इट लाइक 1.04 kg/ms -1. ओके, तो ये हमने बॉल वाई का इनिशियल मोमेंटम परपेंडिकुलर डायरेक्शन में सॉल्व किया है. नाउ इन पार्ट 2, by considering the component of the initial momentum of each ball to the line AB, perpendicular to line AB, calculate to three significant figures Vx की value. By considering the component of the initial momentum of each ball perpendicular to line AB, calculate to three significant figures the value of Vx. हमें Vx को निकालना है. If we just look at carefully the perpendicular component for Vx with the blue arrow जो हमने point किया था, it's pointing in a downward direction and Vy के लिए is pointing in an upward direction. Okay. Or by the way, after impact what is happening? There is no vertical component for either x or either v. Okay, so therefore initial momentum of each ball perpendicular to the line AB, we have to calculate the value of Vx. So use a reference, apply the law of conservation of momentum perpendicular to line AB. Apply the law of conservation of momentum perpendicular to line AB. So before impact, momentum in fact total momentum before impact is equals to total momentum after impact. Now total momentum before impact for both the balls x and y is happening because कि वो मौजूद है, लेकिन after impact there is no vertical component, there is a horizontal component. So what we will do now, mass of x, velocity of vx हमने क्या बनाया है, vx sin 60. It is, let's suppose, happening in a downward direction. Let's take it negative, plus mass of y, vy sin 60, happening in an upward direction, so it remains positive, whereas on the other hand side we have 0. Okay, so now if we shift this quantity over there on the other side of equality, we have mx vx sin 60 equals to, now my vy sin 60 was 1.04, your original is 1.039. see, only vx is left. so यहाँ करता हूँ, vx की वैल्यू क्या निकल आएगी, 1.039 डिवाइडेड बाय mx डॉट sin 60. अब मैं इसको सॉल्व कर रहा हूँ. मास ऑफ x इज 0.3, ठीक है, 0.3. सो नाउ 1.039 divided by 0.3 into sin 60, it's 3.99. The velocity is coming 3.99. We apply the law of conservation of momentum in a perpendicular direction. Okay. Now, what is suggesting that, show that the speed of the two ball after the collision is 2.4. And by the way, in the situation after collision, both the balls are embedded together. They are joined together and moving in the same direction. So over here, the bodies collide करती हैं, they stuck up, so their masses usually added up as a combined mass, mx plus my. So let's assume they are moving with a velocity v. They are moving with a velocity v, and we have to show that this velocity is 2.4 ms minus 1. So now what you will do, you will use a reference again. याद रखो, फिजिक्स का सवाल सॉल्व करना है, always use references. That shows a clarity of concept from the candidate side. All right, apply the law of conservation of momentum parallel to line AB. Now in case parallel to line AB, total momentum before impact must equals to total momentum after impact. Now total momentum before impact for x direction, we have Vy cos 60 and Vx cos 60, क्योंकि ये दोनों वेक्टर्स इसके ये तो परपेंडिकुलर बनाए थे, एक यहाँ बनेगा, राइट, दिस विल बी Vy cos 60 और ये होगा x का Vx cos 60, और दोनों क्योंकि एक ही डायरेक्शन में तो ये एडअप है, एडअप हो जाएंगे. सो नाउ मास ऑफ x Vx cos 60 प्लस मास ऑफ y Vy cos 60, दोनों वेक्टर्स एडअप हो गए, राइट. ये टोटल मोमेंटम बिफोर इम्पैक्ट है अलोंग पैरेलल डायरेक्शन एंड दे आर इक्वल्स टू टोटल वेलोसिटी v, कंबाइंड वेलोसिटी v with a mass of mx plus my. Now mx is 0.3, right? Yes, mass of x is 0.3. So 0.3 into Vx we obtained 3.99. I'm sorry, ये एक मिनट गड़बड़ हो गई. All right, okay. Now Vx is 3.99 into cos 60 plus my was 0.2, mass of y was 0.2, velocity of y was given to us is 6 into cos 60 equals to v 0.3 plus 0.2. Now I'm solving the left hand side first. 0.3 into 3.99 into cos 0.3 into 3.99 into cos 60. Hold on, ये कुछ कैलकुलेटर में गड़बड़ हो रही है. Okay, 0.3 into 3.99 into cos 60 is coming 0.5985 plus 0.2 into 6 into cos 60. It's coming 0.6 divided by 0.5 is equals to V. Now 0.6 plus 0.5985, we're getting this divided by 0.5, it's coming 2.39 ms minus 1, which is the required velocity he is asking about. So guys, see, this was for a marks of like 2 and 1, 5 marks total altogether, and that's a question where you need to discuss the momentum along momentum of a particle, of a system of particle moving with an angle. Right now the angle is given to you before collision. There will be a situation where angle is also given to us after collision. All right, thank you.